An important example of the work done by a varying force is the work done by a spring. Okay. We will consider here what we call the ideal spring. We call it the ideal spring. The ideal spring is the spring that perfectly follow the Hooke's laws. The Hooke's law. That is, if we write down the force from the spring is equal to the minus kx. It means that if you have an ideal spring and you attach an object to the spring, and if you, for example, pull this object away from the equilibrium point, which we put the origin of our coordinate system here. This is a equilibrium point. The equilibrium point is defined as the point that the spring will exert the zero force to the object. So, if this is the displacement of the object from the equilibrium point, we have that the force on the spring, the force of the spring on the object is equal to the minus kx. We can see that the force is proportional to the distance of the object from the equilibrium point, and the direction of the force from the spring is opposite to the direction of the displacement. Okay, in this case, we can see that this is the direction of the displacement, and the direction of the force from the spring is opposite to the direction of the displacement. Okay, so this is the force from the spring, and we can see that it is a function of the position of the object. In general, this figure shows the direction of the force on the spring. You can see that if we pull the object to the right, so this is the direction of the displacement, and the direction of the force is opposite to the direction of the displacement. At equilibrium, Fs equal to 0, and if we push the object to the left of the equilibrium point, we have that this is the direction of the displacement, and the force from the spring is opposite to the direction of the displacement. Since the force from the spring is a one-dimensional force, we can write down the diagram for the force as a function of the position. You can see that when the position is positive, when the displacement is positive, the force is negative. This negative side tell us that the direction is opposite to the displacement. And when the displacement is negative, the force is positive. And as we mentioned in the last section, if we want to calculate the work done by the force, and if we can write down the diagram of the force as a function of the displacement, the work done is equal to the area under the curve, and we will show that this is the case also for the force for the work done by the force from the spring.